Hey guys, it's Vince. Today in this video, we're going to be covering a topic that comes up too many times per month, and that is about CNC grounding. And in this particular video, we are going to take a look at a YouTube content creator that feels they can instruct you on how to ground your CNC chassis. Now, in order to understand the depth of what we're about to cover, I suggest setting some time aside. I even suggest watching this video again because, once again, my inbox gets filled with more questions on grounding than virtually any other topic in the CNC genre. This is not an easy subject to understand. It's going to take time for you to implement it on your particular system, and that is the main variable that creates so many different issues for guys to actually get a properly grounded system. Let's jump right in.
The Universal G-Code Sender says that it has sent the commands to the CNC machine, but it doesn't have a done check mark or a response OK. What that's telling me is that the stepper motors are being sent the command of what to do through Universal G-Code Sender, but the encoders inside the stepper motors aren't saying that their position, their required position, has been met.
All right, guys, so we hear the content creator already explaining a stepper with an encoder. That's a definitive red flag. And for my new guys out there, why it's a red flag is because steppers do not use encoders. Servos do. This is a critical misunderstanding that once again defines that this content creator needs to do some research on what motors he's actually working with. If his motors do indeed have encoders, they are servos. If they don't, then they are a stepper motor. One is an open loop system, one is a closed loop system. Open loop, real simple. There is no encoder to once again give feedback position on the motor shaft. Closed loop, there is an encoder to give feedback position on the motor shaft. That's the depth I'm going into this video dealing with a servo or a stepper. Lots of research has been done online. I've covered it many times on my channel. If you want more in depth, you can check that out. Overall, though, I cannot emphasize enough, if we see a content creator bring up terminology used incorrectly, that should be a definitive red flag. Now, I have some guys say, well, you're being really critical. No, I'm being really truthful because, again, if the terminology is used incorrectly, odds are, the majority of time, you will find that throughout the video, you're going to see things done wrong. And the thing I tell you all with CNC robotics is it's all about the details. One detail can make the robot unstable. One detail can make the robot unsafe. And that principle carries over into all variables of this genre.
Based on what I've been reading online, the biggest cause of this is usually electromagnetic interference. So today I'm going to try to take out any possible causes of electromagnetic interference with the CNC machine.
All right, guys, so we're already up to the second red flag. The issue with this is, of course, that the more we go through these videos and the more you guys check out my channel, you'll notice many of these content creators battle what they assume is EMI at the end of their controller build. Now, many of you, like me, ask, why is that? Well, the main reason that is because they're not being honest with themselves in the amount of research and depth of knowledge it takes to assemble one of these controllers correctly to avoid the mishap of having to spend more money and more time correcting what they did instead of just building it correctly the first time. Think about what I just said. Not only do you have to spend more time and more money to correct the controller after the fact, but you also spend more money on substrates being ruined or projects being ruined or losing clients if it's done incorrectly the first time around and you commission the robot and start producing with it only to find out, yep, you're SOL. So remember, these are things you need to really take into consideration. This person, whoever it is, once again, whether it's someone online arbitrary in an actual forum or some other venue, you have to make sure that what you're trying to absorb is coming from a validated source. You do not want to shoot from the hip. And that's usually what happens with guys like this, that once again, They fall into the realm of, I want to do things on the ultra cheap. And when you do things with CNC robotics on the ultra cheap, all you end up doing is shooting yourself in the foot. Because if you don't have the proper budget to actually formulate a controller for production, you're screwing yourself. And in the end, it costs you more time and more money. And I've seen clients actually get out of the industry because of that. They've actually looked at it and said, you know, this is too much for me. I can't afford this. I have to keep going back and adjusting things and changing things. And it usually all boils down to, I just don't have the knowledge and I can't accept that. I can't be honest with myself, be humble enough to say, I need to get a validated source so we can isolate this from the beginning and make sure I institute best practice from the beginning, making sure the robot is where it should be.
All right, let's look at base conditions right now. So my thought is none of this aluminum extrusion on the CNC machine is connected to the ground terminal inside my control panel. I'm pretty much positive it's not, but we should test anyways.
Okay, I believe we're past the red flag portion of this video. We understand that the content creator is basically covering a video on CNC chassis grounding, yet he's saying he's almost positive that the aluminum extrusion making up his CNC router's chassis is not connected to his CNC electronics enclosure's ground bus. Well, we know that must be the case, or you most likely would not have followed through with this video. That's just a point of logic. So that being said, if we know that the CNC chassis is not properly grounded, the base level format of what you guys should be doing is contacting your CNC manufacturer if you've purchased a system that includes the actual chassis and the CNC controller in more of a turnkey solution. If that's the case, they should be held accountable for them to provide you the required instructions to ground that chassis properly, and it should have been covered prior to you even buying the machine. That should be covered in prototype stage so that once again they can provide that to their end users so that they know and are aware this must be done not only for safety but also stability of the robot. For some reason, guys keep buying these ultra low price kits and then they wonder why they have so many issues with them in terms of stability and in terms of setup. We have to execute logic. And when I say that, it's apparent you're buying an erector set. And for some reason, guys don't realize what I'm really buying is someone who did not complete the engineering at the level that's required to produce a stable production robot. And I think there are always two types of people. There are people that want a ready-made production robot regardless of the size. And then there are people that don't mind tinkering. If you're a tinkerer, then these are the machines for you. If you're a person that wants to hit the ground running, and I do consultations and discuss this all the time, then this is not the machine for you. Okay, if you have a product that you're ready and you just need a robot to cut that product out or to aid in assembling that product in some way, shape, or form, I'm telling you right now, buying something like this where once again no instruction is provided, that's what I typically hear, the vendor's not giving me instructions or they don't even cover it or I have to go online to do research on it, then you already know you're getting screwed. And you shouldn't be funding these people to basically learn what they should have already provided from the beginning. But then when you come to someone who's validated and they sell you a machine and you wonder why it's thousands of dollars, now you know why it's thousands of dollars. This individual right here reflects that not only is the CNC chassis he's working on ultra cheap, but the router he's using is incorrect. And when I say router, I'm talking about the box store router that he has mounted to the robot. Now, why do I say that? I've had clients tell me many years that, hey, I'm right now starting out with a box store router. Well, here's the thing I always make them aware of. These box store routers generate large amounts of EMI. They are not ever designed for CNC robotics use. When I see a box store router, the first thing you have to consider with that is the cables can never be shielded unless you want to modify that box store router. And for some reason, guys don't think at this level. They think they're saving money because they're buying this unit. But let me ask you this. Do you really think that this end user is saving money having the problems he is? Because if that was the case, he wouldn't be making this video. He'd be making a video telling you, hey, you know what? Buy the box store router. It saves you money. It doesn't. You have to execute common sense. Box store routers in any way, shape, or form are not designed for CNC robotics use. Any vendor selling a CNC router or CNC robot implementing the use of these tools, which are a separate tool designed to be used by hand, they are not going to perform at the level you're expecting. And that means instability. It means you having to spend more money, possibly destroying substrates. Be realistic. And the guys that know, on top of you always having to wear ear protection because the units are extremely loud, especially in a confined space.
So this, as most of you know, is a multimeter. And it has a function, I think it's called a continuity function or maybe a chime function. I don't know what they call it. But basically, what happens is if these two probes register 0 resistance between them whenever you put them on something, then it'll make a sound. It'll sound like this.
All right, so it's apparent the content creator is not really aware of how a multimeter works, at least not at the capacity that he needs to in order to reference this machine as being grounded. That being said, I'm going to put a link here for a video teaching you how to use a multimeter, understanding its features, and once again, you will then be able to use it as the tool was designed to test for grounding your CNC chassis. Now, the thing to keep in mind is this. Just because two probes come into contact and you register continuity, which is exactly what the content creator was trying to explain, if that happens, you do not have a grounded chassis. Now that's something different than what you've heard online. For some reason, the consensus is if we have continuity, and all continuity shows is that there is a connection leading from the chassis to a ground source. If that happens, it means that connection is a positive connection in that they are connected. But it doesn't register the resistance. You have to measure the ohms, which is the resistance that this connection has. If the resistance is too high, then your robot's chassis is not grounded. That is the detail that is extremely critical. If we cannot dissipate EMI correctly to the ground of the chassis, essentially what you're doing is creating a obstructive path for that EMI to get to that point where it's grounded to dissipate, and basically what it does is it slows down that connection to where it hangs. And if it hangs and it's not transferring fast, it can possibly cause an unstable robot. Now this is what this content creator simply doesn't understand. And also thinking in terms of what you've read online, forget it. Because most of what you've read online is guys just touching the probes together and saying that they have continuity. Or guys who really don't understand multimeters any more than what he's just explained. You have to understand the tool you're working with, and you have to understand all of the variables and the details of this machine in order to make sure the machine is going to be stable, and I cannot emphasize that enough. If you are uncertain, you are far better setting up a time with a validated source to cover the proper grounding process. The best practice, as I've stated earlier, would be for you to contact the chassis manufacturer. And honestly, it's the cheapest process, because if you're asking for third-party support, and I can speak only for myself, I am going to charge you because you didn't purchase your equipment from me. So again, this is just logic. It should just come as a point of understanding that these robots are not simply plug and play. If you buy something like this, you better understand all of the tools that are required to run it, because otherwise, when a content creator says, oh, all you need to do is touch probes together and you're good. No. And that's why so many guys have problems.
I'm going to put one of these on my ground terminal inside my control panel. And the other one, I'm going to go around and start testing random points on the aluminum extrusion and seeing if it actually chimes. I really don't think it will, but let's give it a shot.
I have no idea why he keeps acting as if he doesn't know if the CNC chassis is grounded. Once again, the video would be pointless to show the audience how to ground the chassis if indeed it was already grounded. Just pure logic.
All right. Ground terminal's hooked up, so let's start testing. No chime there. No chime there. No chime there. No chime there. Nothing.
All right, once again, here's where the details count, guys. Before you ever make contact with any of the multimeter probes to your chassis or ground bus, what you need to understand first is look at your chassis carefully. Analyze the fact, are all the adjoining components that make up the chassis conductive? Think about what I just said. If it's not conductive, and let's say your gantry is on plastic wheels, then you're going to find that those plastic wheels are an insulator. This is fact. This means that, once again, conduction is not present. What is conduction? Conduction is where adjoining components have electricity that can flow through them. Because, once again, electricity will flow through unobstructed metal, meaning it's adjoining. If that metal, however, has anodized coatings, if it has plastic insulators, if it has rubber bushings, if it has plastic bushings, anything that would hinder electricity from flowing through it, you will not have a proper conductive chassis, and therefore continuity will not be present when you go to ground the chassis as a whole unit. Now, why is that critical? Once again, our content creator here didn't cover this. It's critical to make sure the chassis is grounded as a singular unit and not grounding each piece individually that can potentially have multiple ohm ratings, because then we have different resistances per se for a gantry than we would for the y-axis. That would make no sense. The idea is to ground the chassis as a whole, and in order to do so, you must have metal-to-metal contact in full conduction, and make sure that if your transmission has insulators, like cheap plastic wheels or any other component that's not made out of conductive material, that this is corrected. Now, I want you to think about what I just said there. If your transmission has plastic wheels, this is not an easy thing to correct, because now your transmission is using plastic, and now you have to formulate a plan to get that z-axis to be a conductive unit by itself, which means then you must ground it independently. Now, is it still possible? Absolutely. It just makes your job harder. And this is once again why most vendors/manufacturers don't cover this, because it's not a simple plug-and-play process. This is not for the typical content creator. And when I say typical content creator, I'm speaking of the ones like this guy who go online, read a bunch of forum posts, and think that they understand the process. If he's really trying to instigate being an instructor, then instruct everyone correctly, because not everyone is using a bare extrusion CNC chassis. As soon as you have any coatings on that chassis, you're going to find out that all of a sudden you have no conduction. And one more thing to keep in mind, when I say coatings, I mean any coating. That means paint. That means anything that's on there that's not a natural metal finish. Any coating applied to a metal chassis will affect the ohms rating. And once again, lower ohms, lower resistance, better path to ground. It's that simple.
So, nothing's currently grounded. Let's go try fixing that. So let me show you what I've done. On 3 places of the CNC, I've routed conductors and bolted them to the aluminum extrusion. These conductors are then routed back to my control panel, and they are all terminated on a single point, and that point is then bonded to the house ground.
Well, once again, we get the content creator making this process sound ultra easy. All you have to do as an end user is attach a ground lead to your CNC chassis, take that other end of the ground lead, go to your electrical enclosure's ground bus, and then just take the electrical enclosure and ground it to your wall outlet or your breaker box. And according to him, essentially you're grounded. Unfortunately, that's not the truth. The fact of the matter is we need to cover the variables, and there's a major variable he overlooked, and that's the leads being used to ground the chassis. Let me explain. A larger CNC chassis has much more conductive mass. Why? Because it's larger. A smaller CNC chassis has much less conductive mass, once again because of the opposite. It's smaller. So what we need to consider is a larger gauge lead, meaning a thicker conductor, is best used on a larger chassis, where a smaller gauge lead is once again best used on a smaller chassis. Once again, smaller, we use a smaller gauge lead. A larger chassis, we use a larger gauge lead. The biggest question that comes up when I discuss this with clients is, Vince, what do you recommend in best practice as far as using what gauge lead? This is a great question. In best practice, it's always going to be using a dedicated ground strap, and that's not a regular lead. Now, what is ground strap? I'm going to put it up on the screen here.
All right, guys, in this portion of the video, I want to cover what ground strap is. And this is actual ground strap. And once again, this is 1/2 inch wide ground strap, which is the most commonly used for most of my clients for their systems. Now, whether you have a tabletop chassis or a larger chassis, these straps are unique. And let me explain why they're unique. We have a piece of 16 gauge wire here. You can see the internal copper conductors. If we look at this ground strap, this is full conductive mass, meaning that there is no insulator on here where this has a PVC casing. There is no PVC casing. So if you need even more conductive mass, you can double or triple this to make contact with itself, and that will give you even more conductive mass. You can also see how extremely flexible this is. Okay, it can actually expand, it can contract. It's very similar to the tin braided shielding we see on most cables. The big difference is it's interwoven a little tighter. It's also made up of very, very fine strands of tin braided copper. Now, the next question I get asked is, how would you use this with a connector? And once again, proper connectors would be similar to this SC25-8 connector. It gets inserted, and then this would be soldered on. Now, if you look at the top and the bottom, we have gaps. Those gaps would all be conductive material, which would be solder and flux. This is the proper way to formulate a ground strap. Now, why is that? When you use solder and flux, that huge gap that you see on top and bottom is going to be filled with this conductive material. There is no crimp connector that would allow that amount of material to make contact with this ground strap. And remember, the more conductive mass we have, the faster we can get any electricity to that ground bus. So this is imperative, and this is why, once again, we use solder type connectors. On top of the fact that if I show you how thin these little hairs are, you can see it right there, there's one. If you went to crimp on these, and we see this done a lot of guys will buy them from automotive, and guys will crimp on connectors. And for that application, if you're okay with, so be it. If you want it soldered on, you're going to pay a lot more, but you can rest assured it's forever. You do not know when you crimp if you're fracturing any of these individual conductors. And I know guys will say, well, you're being very technical. Yes, I am. Because if I want a robot to be stable for my clients who may be working on a sheet of carbon fiber that might be $3,000 or $4,000, they're not going to think I'm being technical. They're going to say, I want it done right. So again, this is the ultimate grounding material. And like I said, there is no comparison in conductive mass. And this is 16 gauge. So even if you went down to, a 14 gauge, a 10 gauge, I've seen guys go down, 00 gauge. The problem then comes with flexibility. You're not going to have flexibility. This is ultimate flexibility. So again, to add more mass, all you would do, and once again, working with it, let me just get a pair of scissors here. You would just cut this carefully, nice and neat. Let's say, and I'm just showing you for example, I want more conductive mass. Just put the two pieces together, and now you have even more conductive mass. But you notice it takes up the same amount of space. So think about what I'm showing you right there. You've just increased the mass of conduction without taking up any more space, where leads, you'd have to keep adding more and more leads. This, you can double, triple, whatever you want, as long as it fits within the connector. And again, these connectors are very wide, and I do that for a reason, because when you actually want to ground, once again, you may need more than one strap. In most larger tables, you'll probably want to use 2 or 3 of these. But you can see exactly what we got here. There's 2 inside that connector. And you can see just what we've got. You clean up your leads. And the best way to do this is just make sure those leads are bottomed out. And then what you would do is, once again, with capillary action and using the proper solder and flux and a proper soldering iron. Now, this soldering process for this unit is a lot different than using a typical soldering iron or soldering station, because you need much more heat. All right, so for the soldering process with this connector, you need much more heat. And that's where I come in my old Weller. And I'm not a huge fan of these type of irons, except when you're doing much hotter work. And you'll notice I made my own tip out of copper. And this is just copper wire right here. And right there you can see there's the solder. She's already tinned. And this allows me to generate enough heat to once again get that capillary action to solder this connector on this ground strap. So again, a little bit different, need a little different tooling to do it. But if you do it correctly, you will have an amazing connection. I've had guys even in the automotive industry actually buy these from me, mainly because it allows, again, for proper grounding. If you want proper ground dissipation, I cannot emphasize enough, this material is the easiest to work with in terms of flexibility and in terms of mass for conduction. So if you guys need this, just let me know. I can put a kit together for your system. Most of it is based on that. I mean, there's a lot of individualistic properties when it comes to this type of material and purchasing it. Once again, how big is your table? Where are all of your ground locations going to be? I mean, a lot of guys have that planned out, some don't, and that's where we'll cover it and then put the package together based on that. Because again, these are just the ground straps, and then you'll have your ground bus. And the ground bus would actually be mounted to the chassis, and this would just connect to it. And then therefore you're all set. And you'll see that in video as we cover it more and more. You'll see exactly what a ground bus is. This would once again have a bolt in it, and you're all set to go. Now, naturally, if you have a smaller table, you're going to require much less of this material, because this is a lot more conductive material than for a larger table due to the size of it. So a larger table, like I said, would probably use 2 or 3 strands of this, and you'll have a really, really nice, thick amount of conductive material for that ground. So you wouldn't need necessarily 1, 2, 3 individual straps. You might do 2 in this format and just do that across the table. Like I said, grounding solutions are really based on the principle of what table we're working with and what properties we're working with. Is your Z-axis insulated? If it's not, then we can figure out, maybe a single strap solution. If it is, then we'll worry about connections in different locations so they won't interfere with the movement of the X-axis. So these are things to think about, guys. And again, this is why understanding what makes the most sense in terms of how to ground, because looking at this, like I said, of a 16 gauge lead, and then looking at the conductive material here on ground strap, there is absolutely no comparison, none. So keep that in mind, and keep in mind one thing: more conductive material for when you're grounding means that you are going to have a faster path to ground. This is no different, once again, than the analogy of using a wide pipe to allow water to flow. The more conductive mass we have, the faster electricity can travel. Very simple.
So you guys can look at it. Essentially what it is tin braided copper that's woven. It looks more or less like a shield. The difference is it's much thicker in the sense that there are many more strands making up this tin braided copper. And the thicker you get, because you can get different widths, you get more conductive mass. That's right. More conductive mass essentially means that we can once again mitigate resistance, because more mass that's conductive means that more flow is present. Think of the analogy of a pipe. A pipe with a larger diameter means that more water can flow through it. A pipe with a smaller diameter means that less water can flow through it. So if we're looking at it from that perspective, a small conductor carrying a small amount of conductive material is less efficient than a large conductor with greater surface area of conductive material for, once again, efficiently transferring electrical energy. So it's the same principle. The idea is to take that EMI that's present in the air, catch it, and dissipate it as fast as possible to ground before any possible corruption of signals would take place, once again yielding an unstable robot. These are why understanding these details are critical. This is what I am paid for in my consultations. I'm not paid to be your friend. I'm not paid for you to like me. I'm paid for me to send you the right information and make sure that not only do you have the right information, but you understand that process of implementation to get the result you're looking for. And to me, that's of great value, because I know for a fact many of my clients would not be able to achieve the income level they have if their robot was unstable. That's where an end user has to put value on not just my time, but my knowledge. So when guys are giving away free information like this, think of how much you would have paid in a consultation for me to just discuss at the level I have what we've just covered in just this brief portion of the video. As we go through the video, you're going to see more and more details come out. And these details all will typically draw more questions to end users. So once again, if you find yourself confused, that's fine. Watch the video again and come up to that point to where you're confused, and just keep reviewing it as the information will become easier to digest. If that doesn't suit you, then I highly recommend scheduling a consultation, once again, someone who's validated with the proper knowledge to get you on the correct path.
So everything should be grounded. So I've got one connection for the bottom of the CNC. I've got another connection for the gantry and another connection for the Z-axis. And the reason I did that is because every place I have a gantry or a movable part, it's all routed on these V-wheels. And these V-wheels are just really hard plastic.
And here is what happens when someone misunderstands the actual grounding process, in that a simple connection to ground on your chassis does not mean your CNC chassis is grounded. You should be registering an ohms rating of 3 or under. Now, Lincoln Electric, this is the PDF manual dealing with EMI reduction and grounding. And again, I use this as the Bible because, again, their engineers are top notch. They do understand the process. And once again, they are a validated source. Their tables are in excess of $50,000 to $100,000. And I can tell you that they're dealing with the most elaborate type CNC production robots in existence, which is plasma cutters, which once again deal with large amounts of EMI, much greater than anyone using a mill or a router. Therefore, following their principles essentially guarantees success if you understand it. That being said, you can see here on screen what they recommend, and I always tell my clients I like an ohms rating of 3 or under. They say under 5. The preference is yours. For robotics use, bottom line, your shop needs a minimum of 5 or under. I prefer 3 or under. Lower numbers are better. The lower your chassis is with resistance to ground, the faster it can dissipate any potential EMI. It makes it more efficient, and therefore that's what you should be shooting for in best practice.
There's no electrical continuity between the two. So to make sure everything's bonded, I just had to route 3 conductors. Okay, I've installed all of my ground connections as I showed you. Let's try doing that continuity test again. So I've got my multimeter. I'm going to take the probe. I've already attached the other side to the ground bus and my control panel. Let's go tap around and see if we hear any noises. Yep, there we go. So it seems to be working. So we know that the whole frame now is on the same potential. Let's see if the gantry is. Gantry is at the same potential. Both sides of the gantry. Let's test the Z-axis. That's perfect. The springs are even grounded. And let's see if this is all robust enough to even just ground the frame of the router. I don't know if it will be. Hot dang. So that's good. So that means that everything, all the metal on this machine, is now connected to a single point, and that point is connected to ground. And hopefully that...
So now I'm happy to say that all of you in my audience have just experienced what I experience as a vendor engineering systems and have dealt with for years. And that is that end users claim their CNC chassis is grounded when asked. And all that simply means to them is, yeah, I've connected a lead on my chassis to my ground bus, or a lead on my chassis to the ground in my outlet or breaker box or ground rod, and that's it. That's where it ends. And then my next following question, as many of you have already guessed, is what is the resistance on your grounds that are attached to your chassis? They don't understand that. Then I say, okay, what's your ohms rating? Because it should be 3 or under to be considered the robot grounded. Did you verify that? No, I didn't. There you go. So again, am I making this up? Am I just a guy that wants to make, trouble to these people? No, I'm showing you fact. And whether or not you want to take these facts and utilize them as the tools they are to make sure your robot's stable, then that's totally up to you. But once again, there's always those guys who get butt hurt. The fact of the matter is that this content creator is getting paid for a video that is blatantly done incorrectly. He's done no research. The research he has done has turned out to be misinformation if he actually did acquire it from any forum, which, like I've said, has proven time and time again to be inaccurate. Why would you listen to people you've never met? Would you let this same person do surgery on you? I think not. But again, this is what happens when we use social media in a way that it is not being fully thought about. You have to remember the people in forums, the majority of them, are people that are having issues. If they are having issues, what makes you think that they're going to be able to solve yours if they can't solve their own? It's a logical question. We all have to think about it. For some reason, it happens all the time. When you have validated sources, yes, that are not free if it's third-party support, then you have to put money where your time is, because you're going to either pay with time, pay with intelligence, or you're going to pay out of your pocket to get the correct information. I've just provided it to you. This video has shown, once again, this content creator is blatantly dispersing misinformation. Matter of fact, to be all truthful, he used the word potential when connecting the probes to the chassis. That is not what he was determining when connecting the probes to the chassis. He did not measure potential at all. My electronics guys realize that. But again, he's trying to act as if he is an authority to some degree, because no one would show a video like this if they weren't trying to portray that. Unfortunately, he failed. And the question now comes, where do we draw the line? Do we draw the line at saying it's okay to put up a video regardless of the fact of what research is being done? If we don't know the research is accurate, then maybe we shouldn't post until we know that 1 + 2 actually equals 3. Does that make sense? Again, my logical people out there see my point. And there's always going to be people that disagree. We can agree to disagree, but facts don't care about your feelings. And I'm telling you right now, this is fact. If the system is not grounded properly, you will encounter problems. I'm going to leave you guys with a best practice diagram that shows, for the majority of you, how to ground your chassis in the simplistic fashion I've discussed. You will utilize a ground bus. You will make sure there are no coatings that would be non-conductive, that would hinder the principle of conduction I've discussed in this video. And on top of that, you now know what ground strap is, and all you have to do is decide if you want to use it or a lead or whatever else you decide. But you certainly now have the tools, and accurate ones for that, to produce a grounded CNC chassis.